Okay, this is Geometry 6.1, similar figures. So two figures are similar if they have the same shape but different size. Okay, so I've got a couple examples here, and let's also go over the symbol. So this is the squiggly line is the symbol for similar. It's kind of like just the top part of the congruent symbol, right? The congruent symbol is the squiggly line with the equal sign, that's congruent. And just the squiggly line is similar. Okay, so let's move on. Similar polygons. So two polygons are similar polygons if corresponding angles are congruent. Okay, so we've got picture SIMA is similar to LURE. So I've got two trapezoids here. And basically, with these being similar polygons, I know that these corresponding angles will be congruent. So S will be congruent with L, I will be congruent with U, and so forth. So we can go ahead and show that with our congruent markings. So angle S is congruent with angle L, angle U is congruent with angle I, angle M, there you go, 1, 2, 3, is congruent with angle R, and last one, angle A, 1, 2, 3, 4, is congruent with angle E. Okay, we could also write that out. Angle S is congruent with angle L. Angle U is congruent with angle I. Angle M is congruent with angle R. And angle A is congruent to angle E. All right, and so what we also know about similar figures is that they set up proportional relationships. So let's say we knew the length of SI was 2 inches and we knew that the length of LU was 4 inches. What we can say here is that segment SI, the distance from SI, is proportional to the distance of LU. And this will be true with all of our side pairings. So IM will be proportional with UR, MA will be proportional with RE, and AS will be proportional with EL. Okay, so if I didn't know one of these values, let's say I know that SA is 4 inches, how would I find X? Well, if I were to substitute these out, okay, let's go with, SI we said was 2, so I'm just replacing, the segment with the distance, and LU is 4, and SA, so I'm looking at this one here, so SA is 4, and LE, we don't know. So we could put an X there, cross multiply and divide, we get 16 is equal to 2x. Divided by 2, we're left with x is equal to 8. Okay, and you probably didn't need to do the whole work on that one because you probably see that this one is just twice as big as the small one, but it's helpful to see the workout even on the easy problems. Okay, so let's move on here. So now we're looking at corresponding parts. Okay, and we're gonna look at this just the same way we did with congruent figures. So I'm looking down here, it says triangle UTS is similar to what? So remember, with congruent figures, the order really mattered. Same is true with similar figures. So UTS, we go from U to T to S, right? So if I start at U and I go to T and up to S, I need to do the same thing with the other triangle, okay? So I went from the smallest side length and then I went to the largest side length. So I need to do the same thing here. So I'm going to go from E to F to G. Okay, so triangle EFG is similar to triangle UTS. Okay, and so all of these side lengths are going to be proportional to one another. Okay, so let's go ahead and write this out. I always like to label these as like the bigger figure and the smaller one. So I have, I'm going to do the small over the big. Okay, so and then even with that, I've got the smallest length, right, which would be on the smaller triangle is 14, is going to be proportional to the smallest on the big triangle, which would be UT. So that would be 49. And the middle length, right, would be SU here. And the middle on the smallest triangle would be FG, 24. So this one is going to be 24 over 84. And the largest side length is going to be the hypotenuse, FG for the smallest and ST for the larger triangle. So this is 28 over 98. Okay, and so when we're looking for the scale factor, all we need to do is divide. And we can divide actually the top by the bottom, or we can do the other way around, because we can look at this both ways, right? We could think about, going from the smaller triangle to the bigger triangle, or we can think about as going the bigger to the smaller. Okay, so let's go ahead and pull up our calculator here. And let's show you that these should all give us the same answer because the proportion is the same. So 14 divided by 49 is 0.2857. 24, there we go, divided by 84. There you go, 0.2857. And the last one, 28 divided by 98 is the same thing. Okay, so and that is how it needs to be, right? That's how you know you have it set up. They're being increased by the same thing, increased or decreased. Okay, if we went the other way around, let's just take the first one here. If we did 49 divided by 14, okay, that would be like thinking about going from the small triangle to the large triangle. So either one works here. So our scale factor could be either 0.286, we'll round, or it could be 3.5, depending on if you're going from the large to the small or the small to the large. Okay, so I'll just one last way just to clarify here. So if I multiply 14 by 3.5, what am I going to get? Let's clear this out. 14 times 3.5, we should get 49, right? Because we know that the small triangle here is proportional to this, or the smallest length on our small triangle is proportional to the smallest length on our larger triangle. Okay? All right, moving on. So what if I know this side length here? I know this one is 18, this one's 24, and I need to find this side length. So what we can do is we can look at these similar figures and set up proportion. And I always say the easiest way to do this is look, one's going to be smaller, one's going to be bigger. So here's the small figure, here's the big one. Let's just set up a proportion. So small to big, what do I know? 12 is to 18, right? This kind of the slanted side here goes with this slanted side on the big on the big figure. So 12 is to 8, as x is to 24. And then from here we can just cross multiply and divide. 12 times 24 divided by 18. These go together, and these two go together. So x times 18 is just 18x, and 12 times 24 is 288. And then we divide it by 18, and we're left with x is equal to 16. Okay, and so you always want to like kind of go back and make sure that answer makes sense. So if this side length is 12, could this be 16? Sure, that makes sense. Okay, like if you got a really big number or a really small number, it just wouldn't make sense, right? If you got an answer like 160, right? Like there's no way if this side length is 12, this one can't be 160. So you did something wrong if you get an obviously too big or too small number. All right, let's do another one. So some of these are tricky because they can be rotated. You know, one's smaller, one's bigger, and they could be rotated like this one is here. So let's see. If I know this side length is 14, I know this is 8. This is 4, and I need to find this side length. So it's matching up which side length goes with the other. So hopefully we can recognize that this side length corresponds to this one. So I'm going to set up this proportion, right? I've got, again, I'm going to do small to big. So on the small figure, I have 4 corresponds with 8. And with the small figure, I have x goes with 14. Okay, and now we can just cross multiply and divide. 14 times 4 divided by 8, and we're left with x is equal to 7. Okay, we're looking at the back page of 6.1, similar figures. Now we're solving for x. All right, and we're going to be doing the same thing. We're going to be setting up proportions with the small figure to the big figure. So I am going to set up a proportion. Got S and a B for small and big. All right, so I'm going to notice that the smallest side length of the small triangle is 20, and the smallest side length for the large triangle is 24. So these two side lengths are proportional. All right, now I need to figure out what x is, so I am looking at this middle side length, right? And that is on the large or the big triangle, so that is going to go on the right column. So 4x minus 4 goes here, and that is going to correspond with this 30, the middle side length of the small triangle. So 30 goes here, and now we can just cross multiply and divide. So we're going to do 30 times 24, which is 740, is equal to 20 times 4x minus 4. So we need to make sure that we put the 4x minus 4 in parentheses to remind ourselves to multiply by both terms. So we're going to distribute our 20 here. 20 times 4x is 80x. 20 times negative 4 is negative 80. Drop down the equal sign in the 72, and we'll solve for x. So I want to get rid of this negative 80, so I'm going to do the opposite and add 80, which will eliminate it. If I do it to one side, got to do it to the other side. If I add 80, I'm left with 800 is equal to 80x. Last step, divide by coefficient in front of x, and I'm left with x is equal to 10. All right, easy as that. All right, next one here is a little bit trickier, but we can still set it up the same way. We have a small triangle and we have a bigger triangle. Okay, let's line up the smallest side length with the small triangle, which is 3, and the smallest side length on the bigger triangle, which is x. So 3 is going to go with x, and the hypotenuse of the small triangle is x, and the hypotenuse of the large triangle is x plus 6. All right, so we can still cross multiply and divide here. So we're going to cross multiply x times x, which is x squared, is equal to 3 times x plus 6. So again, make sure you put that in parentheses so you remember to distribute. So 3 times x is 3x. 3 times 6 is 18. All right, so we're left with x squared is equal to 3x plus 18. So we have a quadratic here, so we need to factor. So the first thing we need to do is set this equal to 0, but it's very important that you do not try to get this equal to 0 by subtracting x squared. We do not want to do that because we don't want to have a negative x squared. So what we're going to do is we're going to get the right side equal to 0. And we can do so by just subtracting everything out on the right side. And if you do it to one side, you got to do it to the other side of the equal sign. So I subtract this all out. Obviously, these are not like terms, so I'm just going to write them side by side. X squared minus 3x minus 18 is equal to 0. All right, so now we can factor this out. So we're looking for two numbers that multiply to equal negative 18 and that add up to equal negative 3. Okay, so you ask yourself, how can I multiply to 18? Well, I can do 1 times 18, I can do 2 times 9, or 3 times 6. Right, so these are the only three ways to multiply to 18. So it's got to be one of these pairs. Which of these pairs could we also add up to negative 3 based on the our signs? And that is going to be 3 and 6. Okay, because they have to add up to negative 3. We need the 6 to be negative and the 3 to be positive. Okay, and remember these are two set equal to 0, so the x values are going to be the opposite, right? What number minus 6 equals 0? Well, that's 6. What number plus 3 equals 0? Well, that would be negative 3. So x could be 6 or negative 3. That's your answer. All right, moving on. Okay, now we have overlapping triangles. So hopefully we can see this. We have this large triangle here, and then we have this smaller triangle right on top of it. Okay, so when we have overlapping triangles, they are definitely going to have the same angles, so they're for sure similar. So let's fill in some numbers here. So let's say I know this side length is 9, this is 6, this is 11. Say that I know this whole side length here is 12, but I need to figure out what this side length is. Okay, so we can still set this up the same way we did before, where we have a big triangle and a small triangle. So just make sure you find the sides that match up. This one seems easiest to recognize that we have the large triangle or the big triangle. Right here is 9. The side length is 9. It corresponds to this side for the small triangle. So 9 is proportional to 6. And we're looking for this bottom side here. So the bottom side for the big triangle is 12. The bottom side for the small triangle we don't know. Okay, so again we just need to cross multiply and divide. 12 times 6 is 72. 9 times x is 9x. 5 by 9, we're left with x is equal to 8. Okay, last one. Okay, again, we have a set of overlapping triangles, right? We've got this big triangle out here, and we've got this other triangle right on top of it. Okay, hopefully you can see that. Okay, so let's set it up. We've got a big triangle and a small triangle. Okay, so I think the easiest to recognize is that this side length off to the side here corresponds with this side piece For the large triangle, so we have 90 goes with 27, and we need to figure out x. So let's look at the bottom leg. So 4x on the small triangle, so you make sure you keep these in the right column. So it's going to go with the s because that's the small triangle. Is going to go with 80 for the big triangle. And now we can just cross multiply and divide. So we're going to do 27 times 80, which is 2,160, is equal to 90 times 4x, which is 360x, and divide by 360, and you're left with x is equal to 6. And that's all I got for you guys. So why don't you guys give the practice problems a shot. If you need help, come see me. Good luck.